Firstly, thank you, ROOTCON, for having us here. We are a team of three. Unfortunately, Loy and Leo, Lias did not make it, so I'm here. So we are here to discuss about cybersecurity threats to telecom networks, and we have a framework, exploitation framework around signaling protocols, which prominently looks at SS7 diameter, SIP, and GTP. Some of the acronyms to remember for this particular presentation, which we would be speaking about a lot in next few slides. Operator is the telecom operator, subscriber, end users like you and me. SS7 is a signaling protocol which we'll be using for exploitation. So SS7 is usually, it started as a TDM network, but now even it has a IP stack, so which is called SIGFON. MME is responsible for your initial paging and authenticating the mobile device. SGW would be responsible for creating and maintaining a data session for a subscriber. HLR is a database of all the subscriber information, which includes IMSI and encryption keys. So IMSI, you can see it's a there is a unique IMSI for each subscriber, and it is internationally standardized. So no two subscribers would have same IMSI internationally. MSC is a telephone exchange which connects between mobile subscribers. And CRBT, why I have CRBT here is because in one of the scenarios we are going to show how we compromise CRBT. So CRBT is nothing but caller by ringtone, which so when a subscriber wants to opt for a caller back tone, when somebody is calling them and they don't want the calling party to get a traditional tone, that's when they opt for the service. So going ahead with few of the recent attacks that we have seen using SS7 as a attack surface and attacking a third party company or other operators. In specific here, I would like to elaborate on the recent compromise of Reddit. Some of the Reddit systems were compromised using SS7 as an attack platform, wherein the attacker used SMS interception to capture the two-factor authentication of the Reddit employee and was able to get inside the Reddit network and compromise nodes and leak data. Here, the thing is, hence, I think there is a lot of wave around why two-factor authentication should not be based on SMS because due to these type of attacks. And this also highlights issues based on the end-to-end security design implementation by the operator itself. Because if the SS7 filtering would have been in place of the operator ecosystem, then such attack wouldn't have taken place at all. Overview of an high-level overview of an architecture of telecom, how it looks like. So here in the left section, you can see the end user, which are retail and retail customers like me and you, who are subscribers. Here I've divided into three types of customers. One is 4G customer, which is your LTE and VoLTE customers. Second is your 3G customers, people who are still using 3G handsets. And the last is your broadband or FTTX customers. On the right hand side, you can see all the interconnect points, traffic going to internet. IMS is a platform which is used for VoLTE calls. Whenever you place a VoLTE call, your call will first reach IMS PCCF node, and then it will be internally routed and it goes out from the SBC. So that's about it. Key nodes to look at, as we discussed in the acronyms: MAB, SGW, HLR, CRBT, MSC. So MAB and SGW are prominently on the LTE side, wherein when the user connects the phone through eNode gets connected with MAB. MAB looks at the authentication and the paging request. Then the paging request, the request for authentication for data goes to SGW. SGW creates the data session for that particular user, and SGW also maintains that session till the time the user has data enabled or is not moving to various other locations. Looking at where HLR, MSC, and CRBT comes in place is when a user calls and the call lands at MSC. MSC will then look for where the user is. That's where it will go to HLR. HLR will look up in the database saying where the user is and where the location is, if it's in the same area or not. And the record of all the web services of the user will also be there in HLR. That's when the HLR will know that okay, the user has subscribed for a caller back tone. It will reach out to CRBT. It will fetch the media file. Everything happens on signaling protocol. It will reach MSC, and that's when the calling party receives a tone, the ringback tone, customized ringback tone, and not the generic one. So that's how the architecture is placed. Of course, we have FTTH. From FTTH, you have triple play services in FTTH. Some operators give you only VoIP and data. Some operators give you VoIP, data, and IPTV. So that extends the attack surface to IPTV as well. Various entry points to the telecom network. Highlighted are the subscriber ends, which is your mobile device. eNode is the access network as well, because when you drive around, you see a lot of towers around the city, right? So those towers are basically extended part of operators' trust network. So it is extended part of operators' network, and these are points which are not physically secured that way. So even if you go to remote location, you find a node V there, and if it's physically not secured, you can easily get in, figure out which cable does what. I mean, there is a labeling to everything, so you can simply plug out something, plug in your device, and you have access to the operator's network. So that's as simple as that. Even for FTTH, you have OLT, but OLTs are optical line terminals. These are basically so one OLT would have further, it would have a lot of splitters, and that splitters would further be connected to your home CPE. So OLTs, it's difficult to get access to physically, but Node Vs and eNode Vs are easily available. On the other side, IMS, internet. So from internet, every operator has a DMZ zone, wherein so he would give service to enterprise customers and other customers to host their servers, host their application on their data center. And this is where the attacker could come in. He could compromise the node which is part of their DMZ and figure out a way inside the operator's network if there is lack of network segregation. And we have IPX and GRX. IPX and GRX are roaming when subscriber is roaming. That's when the roaming protocols come in picture. And you also have MVNOs, which are virtual mobile operators. So they don't have physical existence, they don't have physical infrastructure as such in the country, but they lease it from the base operator. Attack vector, as we spoke, from the mobile station, which is your 3G, 4G, you could enumerate internal nodes of the operator which are exposed due to lack of network segregation. If it's a VoIP enabled network, you could identify the PCSEF of the network or the UAG, which is user access gateway. This is how it works is when you try to call somebody, your phone directly connects with the PCSEF. So when you go to when you do a next stack while you are on the call, you will get the IP address of the PCCF which is connected to that phone for that session. And that could be an entry point wherein you could enumerate all the PCSCFs in the network, irrespective whether they are connected to your phone or others, and you can send crafted SIP messages to them. And all the SIP related vulnerabilities can be checked here. And if something triggers, then you'll end up getting a lot of information out of that. You can also identify systems which have SIGTRUN enabled. So SIGTRUN is basically SS7 on IP, right? So not TDM, but SS7 on IP, wherein that's how you figure out what nodes have SS7 stack in them, and you can target those nodes and try to connect with them using SS7 stack at your end. From FTTH, you could enumerate internal nodes exposed because of network segregation. Three services, as we discussed, VoIP, you have IPTV and data, so you can do VLAN hopping here and access VoIP, VLAN, and IPTV VLAN. So once you reach out, once you get inside IPTV VLAN, that's when you can access the content delivery systems and streaming servers. In IPTV as well, you can do media packets. You can craft media packets and send across. That way, you will be able to subscribe to channels which you have not subscribed. So basically, unbilled. You use it for free. From internet, you come in, you compromise systems part of DMZ. Due to lack of security control, you can get inside the core network of the operator. There are interesting thing is the core components like VGW, GGSN, SGSN. These are components which you may end up finding it exposed over the internet if you simply look at Shodan or similar sites. You'll be surprised to find there are a lot of systems which are exposed. And over the internet, operator also has SBC exposed because SBC is a session model controller used between two international parties for call routing. If it's there on the international, if it's there on the public domain, then you have routing in roaming interfaces, which is SS7, GTP, SS7 diameter, wherein you can get the IMSI of the subscriber. You can do overbilling to anyone. You could intercept calls and SMSs. So usually what we have seen is we have seen a lot of demos around how to extract IMSI of a subscriber. What people usually do is they have a fake BTS with them. They use hack RF, blade RF to convert to use that as a BTS, and then you roam around and you need to be around the victim to get his IMSI and then attack further. But because the operator has not controlled or not filtered malicious traffic, malicious signaling traffic, so these are services. There are services online available wherein all you need to do is just give the victim's number, and it will from the international HLR, it will query the HLR, the serving HLR, and it will come out. It will give you information about the MC and the serving MSC. Serving MSC is the location where the victim is right now, and the MSC which is serving the victim at that point of time. So if the victim is in a roaming scenario wherein in the screenshot, if you can see, the victim was traveling to Pakistan, and this is actually a colleague's, a friend's number, so it was okay to put it up. So he was traveling to Pakistan. That's when you see the Pakistan GT code. One thing I missed in acronyms is GT number. GT number is basically IP address sort of for SS7 network. That it is unique for each component in each operator. So there is never a dispute in that. Like we could do a demo of this. So this is the friend, I mean, don't note down the number though. This is happening live, querying the HLR, it is triggering, it is going to query this, it's a query number. And so now we have the entry of the subscriber, the victim, and we also have the serving MSC. So now we have the GT number of the operator and the entry of the subscriber. Two types of attack can take place. One is at the operator side and one is at the subscriber side. Operator side, why? Because now we know what is the sequence of GT number that they have, and you can map the operator that way. So you can map all the components of the operator by looking at the MSC GT number, and MG we would use it in further slides. We'll talk about how we can use it. Okay. So there is other thing that we can do is like we do subdomain enumeration in finding bug boundaries. You know, when we get into the program, we do subdomain enumeration. So this is a standard domain 3GPP networks.org, which is a standardized domain structure followed by all the operators. It is followed by all the operators because it makes it easy to route things around different operators. So when you enumerate, when you do a subdomain enumeration, you will be surprised to find a lot of internal components exposed over the internet, like PGW of the operator would be exposed, the EPC nodes, which are packet core nodes, which are exposed, and using these exposed nodes, when you further enumerate, and if there is any application hosted on it, exposed on it, if you are able to trigger any exploit or known vulnerability on those platforms, you may end up getting inside the core infrastructure of the operator without even being close to the operator. So this is, and we could also see test beds which are exposed online on public domain. So test beds are, it's a separate network altogether, and it has to be never be exposed over the public domain. So yeah, that's what we found here as well. So attack scenario, we spoke about CRBT, and we also spoke about how attacker can get in the network. So here what we did is you connect your mobile phone with your laptop, you tether the data traffic, and you sweep the entire network. And if the segregation rules are not in place, you will find a lot of internal nodes are exposed to the subscriber, and then you need to map those components based on the services they are offering, based on the ports that are exposed. And when we drilled down, we found that the particular node was CRBT, and as we've learned now that CRBT has SS7 stack in it, and CRBT is connected with HRR and MSC. So now we can execute signaling messages from this node to core nodes. So we were able to pop a shell because of weak configuration, weak credentials. The key thing to note here is for an operator, the core and the extended network, which is still eNode B and access layer devices, they feel that everything is part of their trust zone and nobody can actually come in. That's where they go wrong. And a lot of devices inside the core network you will find with weak credentials or even default credentials, and the management ports will be exposed to everyone. So in this scenario, it was exposed on the subscriber network. So we were able to pop a shell on that. So using the CRBT node, first thing what we did is we mapped the core network elements, which is HLR, MSC, SMSC, to kind of get the global titles for all the core components. And here in the screenshot, you can see that we found the GT code for HLR. Why GT code for HLR was required in this particular scenario was if the if the operator has any kind of firewall in place, any kind of signaling firewall in place, or around SMSC, if they have a SMSC firewall, the request for IMSI that we send across to the operator, it will not go through because it will be filtered out at the firewall. So then what we do is we target the HLR with specific GT code. It will directly go to that particular HLR without touching the firewall. So here we are bypassing the firewall altogether. We can see Seploid in action. We'll get to the demo. So using Seploid, we send the request for IMSI to the HLR via MSC, SMSC, sorry. But since there is a firewall, we use the GT code for HLR and directly reach the HLR to get the IMSI out of it. So the information retrieved here is the IMSI of the subscriber and the global title of the serving MSC. How we can use this information? IMSI can be used for impersonating somebody, data overwhelming, authentication, all the encryption keys which are required for authenticating the subscriber in the network, so that you can retrieve from here. From MSC global title, you can manipulate the subscriber profile, intercept calls, SMSs, track the subscriber. You can actually track the subscriber and lay out his entire movement over map KML files, and so that's pretty interesting. You can also do DOS attack. So here we've gone a step ahead. So far what we have done is we have enumerated the internal nodes of the subscriber, of the operator. We have identified the IMSI of the subscriber. And now what we do with the IMSI, in this particular scenario, we are going to impersonate as that subscriber and use the data traffic. So we use the data for free and the victim gets charged for it. Way to do it is we simulate ourselves as an enemy and we speak with the SGW and we request the SGW with the MC that we have replied, and we ask the SGW to create a session for us, and everything happens on Cycloid without any glitch. So here we have requested the SGW for a session on that particular MC, and SGW just creates it. Yep. So this is how the framework looks like. It's similar to use with we've taken tips from Metasploit so that people don't find so much change. And we have Wireshark running in case you want to look at the packets. So basically what we are doing here is so what we are doing here is we are going from step one, we are querying the HLR for MZ, and then we go to GTP and we through on GTP protocol from MEB to SGW to get an active session. We have a server running in background, so with the framework we are also giving out server side codes. So if anyone wants to try and be creative with it, you can. So the stack has started and the connection has been established with the HLR. And here we have the MZ, the MSC, GT of the serving MSC and the MZ of the subscriber. We have the MZ of the subscriber. Using the MZ, we have a GTP module which is there in the framework. We use GTP v2 version because it's LTE, and using that, we're going to select overbilling. So a session will be created, a separate session will be created for us using that MZ. So a session has been created by SGW for us. So now we can use that session and the subscriber, victim subscriber will be charged for. How do we reduce the exposure? For all the basic rules of secure configuration should be in place. Does not matter whether the node is internal or is part of DMZ, it should be there. There should be network segregation. What we have seen is operators usually they broadcast even the management interfaces to all the even the management protocols to all the interfaces. So I think that has to be bind with each interface and where the interface leads to. So for example, all the management related services should be mapped with your NOC and SOC and not exposed to even corporate LAN and internet. We need to limit the reachability of nodes from the internet as well as the subscriber network. Secure config checklist. So every vendor, every node that is implemented at the operator, the vendor themselves they come out with the security module as part of their administrative guide. So it is recommended that operator actually goes through those controls and finds actually shortlisted certain control which have to be implemented without fail. So for example, if you are implementing IMS platform, you're moving to VoLT, IPsec has to be implemented without fail. There is no ifs and buts around it because if IPsec is not there, you will end up leaking all your set headers and anyone can get the set header and start fuzzing on it. So yes, and monitoring, especially on the signaling side, you need to have monitoring on signaling protocols because they are something where the attacks are now prominently happening. So yes, I think it's that for me. If you guys have any questions or